Somewhere above 50,000 feet, something is crossing into the most heavily defended airspace in the Middle East. The Khorram Dare radar station, one of Iran's most advanced Russian-built detection systems, is scanning the sky every 4 seconds. It sees nothing. The S-300 battery outside Isfahan, capable of tracking targets at over 100 miles, is fully active. It sees nothing. The Khordad 1-5 surface-to-air missile system, the same weapon Iran used to shoot down a $220 million American drone in 2019, is on full alert. It sees nothing. For 47 minutes, something moves across Iranian airspace with complete impunity. It enters from the west, it reaches its target, it does what it was designed to do, and it leaves. Iran will not know what happened for another 6 hours. No sonic boom. No radar trace, no infrared signature, nothing. Just targets that suddenly no longer exist. This is the B-21 Raider, the most expensive, most secretive, and most dangerous aircraft ever built. A machine so classified that the Air Force won't even confirm how many are flying right now. And its DNA traces back to a graveyard of B-52s burning over Hanoi in 1972. But to understand why this ghost exists, why the United States spent decades and hundreds of billions of dollars building something invisible, you have to understand the disaster that made it necessary. By the end of this video, you'll understand how a catastrophic failure over Vietnam in 1972 created a 50-year chain reaction, a chain reaction that produced the most dangerous aircraft ever built. You'll see how 15 bombers burning over Hanoi forced the United States to rethink everything it knew about air warfare. How a forgotten paper by a Soviet mathematician accidentally gave America the key to invisibility. And why that technology may be flying over Iran right now, doing exactly what it was designed to do, while the most advanced air defenses on Earth see absolutely nothing. And there's one detail about the B-21 that almost nobody is talking about, a capability that doesn't just change this aircraft, it changes how every war will be fought from this point forward. But none of it makes sense without Christmas 1972. December 1972. The Vietnam War has been dragging on for over a decade. The American public is exhausted. The peace talks in Paris have collapsed. And President Nixon needs a way to force North Vietnam back to the negotiating table. His answer: the largest strategic bombing campaign since World War II. Operation Linebacker II. The weapon, the B-52 Stratofortress. 8 engines, 185 feet of wingspan, capable of carrying 70,000 pounds of bombs in a single sortie. This was the aircraft that had kept the Soviet Union in check for 20 years, the backbone of America's nuclear deterrent. It was designed in the 1950s to fly high above Soviet territory and deliver nuclear weapons to Moscow. But here's what mattered in December 1972. It was never designed to fly into airspace defended by modern surface-to-air missiles. Not once. That was never the mission. And Hanoi, by December 1972, had become the single most heavily defended airspace on the planet. The North Vietnamese had spent years building a layered air defense network with direct Soviet support. More than 300 SA-2 guideline missiles ringed the capital. These weren't primitive weapons. The SA-2 could reach 60,000 feet, well within the B-52's operating altitude. Its radar guidance system could track a bomber-sized target from over 40 miles away. And the B-52 was the easiest target imaginable. Its radar cross-section, the electronic signature it projected to enemy radar, was enormous, roughly the size of a small building. Every radar operator within 100 miles knew exactly where each B-52 was, exactly how fast it was moving, and exactly where it would be in 30 seconds. The B-52 was designed to be unstoppable, but nobody had told the North Vietnamese that. And what happened on those first nights would change military aviation forever. On the night of December 18th, F-117 129 B-52 Stratofortresses launched from two bases, Andersen Air Force Base in Guam and Utapao Royal Thai Navy Airfield in Thailand. They flew toward Hanoi in three massive waves, each separated by roughly 4 hours. It was the largest single bomber operation since World War II. The crews knew the risks. They'd been briefed on the SA-2 batteries. They'd been told the electronic countermeasures on their aircraft would jam the enemy radar. They'd been told the routes had been carefully planned to minimize exposure. What they hadn't been told was that the North Vietnamese had been preparing for this exact scenario for years. The first wave hit Hanoi just before sunset. Within minutes, the sky lit up. The North Vietnamese launched over 200 surface-to-air missiles on that first night. 200. The crews described it as a wall of fire SAMs rising from every direction, their rocket motors turning night into day. Some detonated close enough to shake the aircraft. Others found their targets. 3 B-52s were shot down on night 1. Charcoal 1 hit by 2 SA-2s over Hanoi. The aircraft broke apart at 36,000 feet. 2 crew members killed, 4 captured. Peach 2 struck while making its post-target turn. The bomber spiraled into the darkness. 3 crew killed, 3 captured. Rose 1 hit during its bomb run. The aircraft exploded. All 6 crew members killed instantly. 3 bombers, 18 men in a single night. Now, 3 aircraft out of 129 might not sound catastrophic. That's a loss rate of just over 2%. But consider what that number actually means. The Air Force was planning to do this every single night for 11 consecutive nights. At 2% losses per night, the math was devastating. They would run out of B-52s before they ran out of targets. But the commanders believed the losses would decrease as crews gained experience and tactics improved. They were wrong. Night 2 saw more SAMs, more near misses, more shaken crews returning to base with shrapnel damage, but no shootdowns. The Air Force exhaled. Maybe the defenses were weakening. Then came Night 3. December 20th, 1972. The night everything fell apart. The North Vietnamese had spent 48 hours studying the attack patterns, and they had discovered something that would prove lethal. The B-52s were flying the same routes, the same altitudes, making the same predictable post-target turns at the same geographic points. Every single wave followed an identical playbook. The North Vietnamese repositioned their SA-2 batteries. They concentrated their missiles along the known flight paths. They timed their launches to catch the bombers at their most vulnerable moment, the post-target turn, when the aircraft were banking, slow, and presenting their largest radar profile. 6 B-52s were shot down on Night 3. 6 bombers in a single night. 33 crew members killed or captured in a matter of hours. Some ejected into the darkness over Hanoi and were captured within minutes of hitting the ground. Others never made it out of their aircraft. The losses were so severe that crew morale nearly collapsed. Pilots who had volunteered for combat tours began questioning whether the mission planning was going to get them all killed. Some crews openly discussed refusing to fly. In the history of the United States Air Force, this was almost unprecedented. And the strategic implications were even worse than the human cost. The B-52 was not just a bomber. It was the foundation of America's nuclear deterrent, the aircraft that was supposed to penetrate Soviet airspace and deliver nuclear weapons if the Cold War turned hot. If North Vietnam, with a few hundred Soviet-supplied missiles, could shoot down 6 B-52s in a single night, what would happen over Moscow, where the Soviets had thousands of missiles, far more advanced radar, and decades of preparation? The answer was obvious and terrifying. Over 11 days, the Air Force adapted. They changed routes, varied altitudes, compressed the waves to overwhelm the defenses. The losses decreased. By the final nights, the North Vietnamese were running low on missiles, and the bombers were getting through with fewer casualties. Linebacker II achieved its objective. On December 29th, North Vietnam agreed to return to the negotiating table. The Paris Peace Accords were signed the following month. But the cost was staggering. 15 B-52s shot down, 33 crew members killed, 33 captured and sent to the Hanoi Hilton, the infamous Hoa Lo prison, where some would remain for months before being released. The operation worked. The bombers got through. The enemy capitulated. But the Air Force had learned something it could never unlearn. The B-52, the backbone of American strategic power, the aircraft that was supposed to guarantee national survival in a nuclear war, was fatally vulnerable to radar-guided missiles. Not theoretically vulnerable, proven vulnerable, documented in burning wreckage scattered across North Vietnamese rice paddies. And if Soviet-supplied air defenses could do this in Vietnam with export-grade equipment and hastily trained crews, what would happen over Moscow? The answer to that question kept Pentagon strategists awake at night for years. But somewhere in the Pentagon, a small group of engineers had already started asking a very different question, a question that sounded almost insane at the time. What if the problem wasn't the bomber's speed? What if it wasn't the altitude, or the armor, or the countermeasures? What if the problem was that the enemy could see it coming? And what if you could build something they simply couldn't see? That question, what if you could build something radar couldn't see, sounded like science fiction in 1973. Radar had been the foundation of air defense since World War II. Every military on Earth relied on it. The entire architecture of modern warfare interceptors, surface-to-air missiles, early warning systems, all of it depended on one assumption: that you could detect an incoming aircraft on radar in time to respond. What if that assumption was wrong? In 1974, DARPA, the Pentagon's Advanced Research Agency, launched a classified program to find out. They gave it the code name Harvey, as in Harvey, the Invisible Rabbit. The concept was radical. Not faster aircraft, not higher flying aircraft, not better electronic jamming. Something fundamentally different, an aircraft that could absorb or deflect radar waves so effectively that enemy radar screens would show nothing at all. Not a small target, not a faint target, nothing. But here's where the story takes a turn that almost nobody believes the first time they hear it. The physics that made stealth possible, the actual mathematics of how radar waves interact with geometric shapes, had already been worked out, not by an American, not by anyone at DARPA or Lockheed or the Pentagon, by a Soviet mathematician named Pyotr Ufimtsev. In 1962, Ufimtsev published a paper titled Method of Edge Waves in the Physical Theory of Diffraction. It was dense, technical, and to the Soviet military, completely useless. They saw no practical application. It was pure theory. They didn't even bother classifying it. So it sat in an academic journal in Moscow, gathering dust until someone at the Foreign Technology Division of the U.S. Air Force translated it into English. And a copy ended up on the desk of an engineer at Lockheed Skunk Works named Denys Overholser. Overholser read Ufimtsev's paper and understood something extraordinary. If you design an aircraft using very specific angular shapes, precise geometries calculated from Ufimtsev's equations, you could redirect radar energy away from the radar receiver. The aircraft wouldn't absorb radar. It wouldn't jam radar. It would scatter radar waves in every direction except back toward the source. The radar would send out a signal. The signal would hit the aircraft. And instead of bouncing back to the radar, which is how detection works, the energy would scatter into empty space. The radar would receive nothing in return. The aircraft would be, for all practical purposes, invisible. The Soviets had published the key to their own obsolescence, and they hadn't even noticed. The result of that discovery, after years of classified development, failed prototypes, and engineering problems that seemed unsolvable, was the F-117 Nighthawk. It looked like nothing that had ever flown before. Every surface was angled. Every edge was calculated according to Ufimtsev's mathematics. It violated every conventional principle of aerodynamics. Engineers at Lockheed joked that it didn't fly because of physics, it flew in spite of it. But it worked. The F-117's radar cross-section, the signature it projected to enemy radar, was reduced from roughly 5 square meters for a conventional fighter to something between 0.001 and 0.01 square meters. On radar, it appeared no larger than a marble. Remember the B-52 over Hanoi, a radar signature the size of a small building, visible from 100 miles away? The F-117 was invisible from 100 feet. And the proof came on January 17, 1991, the first night of the Gulf War. Baghdad, Iraq, defended by one of the densest integrated air defense networks in the world. Soviet-supplied radar, French-made missiles. A layered system designed to detect and destroy anything that entered Iraqi airspace. The F-117S went in first, before any other aircraft, before the cruise missiles, before the electronic warfare jets, before anything. They flew into downtown Baghdad alone, unescorted, undetected, and struck 31% of all first-day targets. They represented just 2.5% of coalition aircraft. They hit nearly a third of the targets. 0 F-117s were lost, not one. The Iraqi air defense operators saw nothing on their screens. They fired blindly into the dark. They hit nothing. The explosions came without warning, buildings detonating from within, command centers collapsing, communications hubs going silent, and the Iraqis had no idea what was hitting them or where it was coming from. The lesson of Vietnam had been answered. Radar-guided missiles were lethal against conventional aircraft. Against stealth, they were useless. But what the Air Force really wanted was not the F-117. The F-117 was a fighter bomber. Small, a limited payload, only 2 bombs per sortie, limited range. It could sneak in, drop 2 precision weapons, and sneak out. That was extraordinary. But it wasn't enough. What the Air Force wanted was a stealth bomber. Something with the range of a B-52, able to fly halfway around the world without landing. Something with the payload to carry tens of thousands of pounds of ordnance. Something that could loiter over enemy territory for hours, not minutes. They wanted the reach and the power of the B-52, combined with the invisibility of the F-117. They wanted the impossible. And Northrop Grumman built it. The B-2 Spirit, first flight, July 17, 1989. The most expensive aircraft ever constructed, $2.1 billion per airplane. 2. And it was magnificent. Where the F-117 used sharp angles and flat facets to scatter radar like a diamond-cutting light in every direction, the B-2 took stealth to a completely different level. Curved surfaces. Smooth, continuous shapes that redirected radar energy with far greater precision. The F-117 looked like a geometric puzzle. The B-2 looked like a manta ray organic, fluid, almost alien. Its radar cross-section was estimated at 0.0001 square meters. On radar, the B-2, with its 172-foot wingspan, larger than most commercial airliners, appeared smaller than a hummingbird. A bomber the size of a building, invisible as an insect. The problem that burned over Hanoi had been solved. The Air Force had its invisible bomber. The strategic question that had haunted the Pentagon since 1972 How do you penetrate modern air defenses finally had an answer. But that answer came with a cost that almost killed the program. The B-2's stealth coating, the radar-absorbent material that covered every square inch of its surface, was extraordinarily fragile. Not fragile like paint that chips. Fragile like a laboratory instrument that degrades if you breathe on it wrong. Moisture degraded it. Heat degraded it. Ultraviolet radiation degraded it. Even prolonged exposure to regular atmosphere degraded it. Every B-2 required a specially climate-controlled hangar, not a standard hangar, a sealed environment with temperature and humidity regulation to protect the coating between missions. Each hour of flight required approximately 50 hours of maintenance, 1 hour in the air, 50 hours on the ground, being repaired. The Air Force had originally planned to buy 132 B-2s, enough to form a credible strategic bomber fleet, enough to cover multiple theaters simultaneously, enough to sustain combat operations for weeks. Then Congress saw the maintenance costs. 132 became 21. 21 aircraft for the entire planet. Then, in February 2008, a B-2 crashed on takeoff at Andersen Air Force Base in Guam. Moisture in a sensor caused the flight computer to malfunction. The aircraft, a $1.4 billion machine, was destroyed. Both crew members ejected safely, but the airframe was a total loss. The fleet dropped to 20. Then, in September 2021, another B-2, the Spirit of Washington, suffered a fire during a ground emergency at Whiteman Air Force Base and sustained severe damage. The operational fleet, 19 aircraft, 19 stealth bombers to cover every potential conflict zone on Earth, every contingency, every scenario. 19. But here's what those 19 aircraft proved, and this is where the story connects back to what's happening right now. In October 2024, the United States needed to strike deeply, buried Houthi weapons storage facilities in Yemen, bunkers carved into mountainsides, reinforced concrete. Targets that conventional aircraft couldn't reach with standard munitions, and that cruise missiles couldn't penetrate. The B-2 got the call. 2 B-2 Spirits launched from Whiteman Air Force Base in Missouri. They flew east across the Atlantic, over the Mediterranean, and into the Middle East, a round trip of approximately 36 hours. They refueled multiple times in the air. They penetrated airspace monitored by Houthi air defense systems supplied by Iran, the same country whose own defenses we started this video with. The Houthis detected nothing. The strikes hit their targets with precision. The B-2s turned around and flew home. 36 hours, halfway around the world, through defended airspace, undetected. The concept born from the ashes of Vietnam, the idea that sounded insane in 1974, the question that started with an invisible rabbit, had been proven in combat, not in theory, not in simulation. In the real world, against real air defenses, supplied by a real adversary, stealth bombing worked. But those 2 B-2s flying 36 hours each, with the maintenance burden waiting for them, when they returned, also exposed a problem the Air Force could no longer ignore. 19 aircraft cannot sustain a war. 19 aircraft cannot maintain persistent presence over a theater of operations. 19 aircraft, each requiring 50 hours of maintenance per flight hour, each needing a specialized hangar, each costing more to maintain than most countries spend on their entire Air Force, cannot do what the United States needs them to do. The B-2 proved the concept. It proved that a stealth bomber could penetrate the most advanced air defenses on Earth and strike targets with impunity. But it also proved that 21 aircraft, now 19, was never, ever going to be enough. The Air Force didn't need a better B-2. It needed 100 of them. And it needed them to be cheaper to build, easier to maintain, and deployable from any base on Earth without specialized hangars and months of preparation. What they needed had been in secret development since 2011, and in December 2022, they finally showed it to the world. But what they showed raised more questions than it answered. because almost everything about this aircraft was hidden deliberately. And one detail that has emerged since then changes everything we thought we understood about the future of air warfare. December 2nd, 2022. Palmdale, California. Northrop Grumman's Plant 42, the same facility where the B-2 Spirit had been built 3 decades earlier. After 11 years of development under one of the most classified programs in American military history, a program so secret that even its budget was hidden inside other budget lines, invisible to congressional oversight, for years, the Air Force was finally ready to show the world what it had been building. The B-21 Raider. Hundreds of invited guests, military officials, defense industry executives, members of Congress, media from around the world, all gathered in a hangar that had been carefully prepared for this moment. And the world saw almost nothing. The aircraft was rolled out under precisely controlled lighting. It was shown from one angle, only head-on. The front of the aircraft was visible. The top, the sides, the rear, where the engine exhausts and intake geometry would reveal the most critical design secrets, remained hidden in shadow. No overhead photography was permitted. Satellite imaging companies were reportedly asked to avoid capturing the area during the event. The official photographs released afterward by the Air Force were digitally altered to remove classified features. Even what they showed was designed to conceal. This level of secrecy told defense analysts something important. If the B-21 were simply an upgraded B-2, a modernized version of existing technology, there would be no reason to hide the exhaust configuration, no reason to alter photographs, no reason to prevent satellite imagery. The fact that the Air Force went to these lengths meant the B-21 was something fundamentally different from anything that had come before. But at the time, most coverage focused on the spectacle, the dramatic lighting, the patriotic speeches, the handful of visible details. Almost nobody focused on what actually mattered. And what actually matters about the B-21 isn't what it looks like, it's what it changes. Let me explain what I mean. Remember the B-2's fatal flaw? Not its stealth. The stealth was extraordinary. The flaw was everything around the stealth. The maintenance, the cost, the fragility. 50 hours of repair for every hour of flight, climate-controlled hangars, a fleet of just 19 aircraft that could never be in enough places at once. The B-2 answered the question from Vietnam. Can you build an invisible bomber? Yes, you can. But it answered that question at a price so extreme that the answer was almost unusable. The B-21 was designed from the very beginning to solve that problem, not the stealth problem, the usability problem. Start with size. The B-21 is smaller than the B-2, an estimated wingspan of roughly 130 feet compared to the B-2's 172. At first glance, that seems like a downgrade. Less wingspan usually means less range, less payload. But it's deliberate, and it changes everything. A smaller airframe means a smaller radar cross-section, even more invisible than the B-2. It means a lower thermal signature, harder to detect with infrared sensors. And critically, it means the B-21 can fit inside standard military hangars, the same hangars that exist at every Air Force base around the world. No more specialized climate-controlled shelters. No more billion-dollar infrastructure at a single base in Missouri. The B-21 can deploy from anywhere. Now, the stealth. The Air Force calls it next-generation, low-observable technology. The specifics are classified. But here's what analysts have been able to determine. The B-2 was designed in the 1980s. Its stealth geometry was calculated on computers that had less processing power than your phone. The shapes were extraordinary for their time, but they were limited by the computational tools available. The B-21's stealth geometry was designed using 40 years of additional computational advancement. Supercomputers running millions of simulations to optimize every surface, every curve, every edge for minimal radar return, materials, science that didn't exist when the B-2 was built. Coatings that are more durable, more effective, and far easier to maintain than the fragile skin of the B-2. If the B-2 appeared as a hummingbird on radar, the B-21 appears as an insect, possibly smaller. The exact figures are classified, but the generational leap in stealth technology is, by all accounts, enormous. Then there's maintenance. The B-2 required 50 hours of maintenance per flight hour. The B-21's specific maintenance requirements are classified, but the Air Force has publicly stated on the record that the aircraft was designed for significantly reduced maintenance burden. Every public statement about the B-21 emphasizes maintainability as a core design requirement, not an afterthought, not a hope, a requirement from day one. And the cost. The B-2 cost $2.1 billion per aircraft. The B-21's target cost is approximately $700 million per unit. Still extraordinarily expensive by any normal standard, but one-third the price of the B-2, which means instead of 21 aircraft, you can build 100. And that's exactly what the Air Force plans to do. At least 100 B-21 Raiders. Some estimates suggest the final number could reach 150. 100 stealth bombers, deployed globally, maintained with a fraction of the B-2's burden. Invisible to an even greater degree than the aircraft that already proved it could penetrate the most advanced air defenses on Earth. But there's one more thing, the detail that almost nobody is talking about, and it changes everything. The B-21 is optionally manned. Not unmanned, not remotely piloted, optionally manned, meaning it has a cockpit. It can carry a crew, but it doesn't have to. The B-21 can fly fully autonomous missions where the risk to human crews is too high, or where the mission duration exceeds what any human can endure. Missions that might last not 36 hours, but days, loitering over enemy territory, gathering intelligence, waiting for targets of opportunity, striking when the moment is right, and returning home without a single crew member having been at risk. This is not a bomber. This is a penetrating strike platform that also functions as a deep reconnaissance asset, a communications relay in contested airspace, and a command node for autonomous wingman drones. It's a flying command center that happens to also carry bombs. And this is what reinterprets everything we've seen in this video. Go back to Vietnam. The problem wasn't that the B-52 couldn't carry enough bombs. It could. The problem was that the enemy could see it coming and shoot it down. Go back to the B-2. The problem wasn't that it wasn't invisible enough. It was. The problem was that you could only build 19 of them, and each one spent more time being repaired than flying. The B-21 solves both problems simultaneously. It's more invisible than the B-2, and you can build 100 of them and maintain them at operational tempo and fly them from any base and send them without a crew if the mission demands it. The B-2 proved the concept. The B-21 makes the concept usable at scale. For the first time in history, the United States has a stealth bomber. It can actually use like a weapon of war, not a fragile, irreplaceable treasure that flies once and spends a month in a hangar recovering. And in March 2026, the Air Force accelerated production, not gradually, accelerated. Multiple airframes in assembly, flight testing expanding. The timeline moving faster than any public prediction had suggested. The timing was not coincidental, because by March 2026, the United States was already engaged in active combat operations in the Middle East, operations that required exactly the kind of aircraft the B-21 was designed to be. And that brings us to the question that everyone in the defense community is asking right now. The question that makes everything we've discussed, not just history, but something happening at this very moment. Has the B-21 Raider already flown over Iran? Let's talk about what is happening right now. Not what happened in 1972, not what happened in 1991, not what was revealed in 2022. What is happening today as you watch this video? Operation Epic Fury. The Houthis in Yemen, an Iran-backed militant group, have been attacking commercial shipping in the Red Sea and the Gulf of Aden since late 2023. Container ships, oil tankers, cargo vessels carrying goods that supply half the global economy. The Houthis have struck them with Iranian-supplied ballistic missiles, cruise missiles, and increasingly sophisticated drone systems. By 2025, the attacks had escalated beyond anything the international community had anticipated. The shipping lanes that carry 12% of global trade were becoming a war zone. Insurance rates for transiting the Red Sea skyrocketed. Major shipping companies began rerouting around the southern tip of Africa, adding weeks and billions in costs to global supply chains. The United States responded with strikes against Houthi positions. We know because the Department of Defense confirmed it publicly that in October 2024, B-2 Spirits were used to strike deeply buried underground weapons storage facilities in Yemen. Hardened bunkers carved into mountainsides that no conventional aircraft could reach. The B-2 proved the concept worked. Stealth bombing against Iranian-supplied defenses in a live combat theater. Confirmed, documented, on the record. But then the situation changed. Through late 2025 and into 2026, the conflict expanded beyond the Houthis. Iran itself, not its proxies, not its client militias, Iran became the focus. The details of how that escalation occurred are beyond the scope of this video. But the operational picture that emerged was clear. The United States needed to project power not just into Yemen, but into Iranian airspace itself. And Iranian airspace is a fundamentally different problem. Iran has spent decades building one of the most sophisticated integrated air defense systems in the Middle East. This is not the Houthi network, a scattered collection of mobile launchers and improvised radar. This is a layered, redundant, purpose-built national defense system. Russian-supplied S-300 PMU, two long-range missile batteries capable of engaging targets at over 100 miles and at altitudes up to 100,000 feet. The domestically produced Bavar 373, which Iran claims is equivalent to the Russian S-400, one of the most advanced air defense systems on Earth. Tor M1 short-range systems for low-altitude defense. The Khordad-15 medium-range system, the weapon Iran used to shoot down a $180 million American RQ-4 Global Hawk drone in June 2019. Multiple layers, multiple systems, overlapping radar coverage from fixed and mobile installations spread across the entire country. Iran has studied every American air campaign since Desert Storm and has built its defenses specifically to counter American tactics. Penetrating this airspace with conventional aircraft F-15S, F-16S, even F-35S would require a massive SEAD campaign, suppression of enemy air defenses, dozens of dedicated aircraft, electronic warfare platforms like the EA-18G Growler to jam radar, anti-radiation missiles to destroy radar emitters, cruise missile salvos to degrade the network before any manned aircraft could enter. This kind of campaign is expensive. It takes days to prepare. It requires enormous logistical support, and most importantly, it is visible. The enemy sees it coming. They know an attack is imminent. They have time to disperse, to hide, to prepare. But what if you didn't need any of that? What if you had an aircraft that could simply fly through? No SEAD package, no electronic warfare escorts, no cruise missile preparation, no warning. An aircraft that enters Iranian airspace alone, undetected, strikes its targets, and leaves, and the first indication Iran has that anything happened is when the targets stop existing. That is exactly what the B-21 Raider was designed to do. Now I need to be very clear about something. As of the recording of this video, the United States Air Force has not confirmed the operational use of the B-21 Raider over Iran. The specific details of missions within Operation Epic Fury remain classified. I am not going to present speculation as fact. But here is what we can observe. 5 things. 1. The B-21 has been in flight testing since November 10, 2023. That is over 2 years of flight testing by the time operations in the Middle East escalated in early 2026. 2 years is historically consistent with, and in some cases, exceeds the testing timeline for previous aircraft before their first operational deployment. 2. The Air Force accelerated B-21 production in March 2026, a timeline that coincides precisely with the escalation of combat operations in the Middle East, not a gradual increase. An acceleration. Multiple airframes reported in various stages of assembly. The 420th Flight Test Squadron at Edwards Air Force Base expanding operations. 3. The B-2 Spirit was already confirmed operating against similar targets in the same theater in October 2024. This established both the operational precedent and the logistical pipeline, the tanker routes, the communications architecture, the targeting data for stealth bomber operations in the region. The infrastructure to support a B-21 mission over Iran already exists. 4. Open-source intelligence analysts and flight tracking communities have noted unusual patterns at Edwards Air Force Base and unexplained gaps in ADS-B transponder data over the Middle East patterns that are consistent with, though not proof of, stealth aircraft operations. Stealth aircraft do not broadcast transponder signals. When they fly, they leave holes in the data. 5. And this is perhaps the most telling. Iran's own state media has made repeated references to, and I'm quoting, translated reports, invisible aircraft, and cowardly attacks that arrive without warning. This language is notably different from how Iranian media describes cruise missile strikes or drone attacks, which they typically attribute to specific platforms. When they say invisible, when they describe attacks that arrive with no detection, no warning, no radar contact, they are describing something they cannot identify. None of these 5 points is proof. I want to be absolutely clear about that. Each one, individually, has alternative explanations. But taken together, they paint a picture. And here is where I'll give you my honest assessment, not as fact, but as analysis. The B-21 Raider was designed for exactly this scenario, penetrating the most advanced air defenses on Earth without detection, loitering over enemy territory for hours, striking targets of opportunity with precision, doing all of this alone without the massive support package that conventional aircraft require, and doing it optionally unmanned if the risk profile demands it. The aircraft exists, the capability exists, the operational need exists, the logistical infrastructure exists. The production has been accelerated to match the operational timeline. If the B-21 has not yet flown operationally over Iran, it would be one of the most remarkable cases of restraint in the history of military aviation, deploying the perfect weapon for exactly the scenario it was built for and choosing not to use it. I think it's flying. And if it is, if the B-21 Raider has operated over Iranian airspace, then what we are witnessing is the final validation of a concept that began in the burning skies over Hanoi 54 years ago. Think about what that means. December 1972, B-52 Stratofortresses, visible to every radar in North Vietnam. Radar signatures the size of buildings. 15 shot down in 11 nights. 33 men killed. 33 captured. The most powerful bomber in the American arsenal, proven helpless against radar-guided missiles. And now, 2026, the B-21 Raider, a bomber that crosses the most heavily defended airspace in the Middle East and leaves no trace, no radar contact, no infrared signature. No indication it was ever there. Targets destroyed without warning. Air defense operators staring at empty screens. from a bomber you could see from 100 miles away to a ghost that passes directly overhead and leaves nothing behind. 54 years. From visible to invisible. From vulnerable to untouchable. From Hanoi to Tehran. Every pilot shot down over Hanoi paid for this. Every B-52 that burned in a Vietnamese rice paddy contributed a lesson. Every crew member who spent months in the Hanoi Hilton endured something that, whether they knew it or not, would eventually produce an aircraft designed to ensure it never happened again. The ghost of Vietnam. That's not a metaphor. It's a direct line of cause and effect. A chain of decisions, failures, breakthroughs, and sacrifices stretching across 5 decades, from the worst night of Linebacker II to an aircraft that may be flying over Iran right now, doing exactly what it was built to do, while the most advanced air defenses on Earth see absolutely nothing. There's a pattern here, and it's not about technology. Every breakthrough in military aviation, every leap that changed how wars are fought, started the same way. Not with a brilliant idea, not with a visionary engineer, not with a blank check from Congress. It started with a disaster. The B-52s that burned over Hanoi didn't just end an era of strategic bombing, they began one. The smoke rising from those rice paddies carried a question inside it, a question the Air Force couldn't ignore, couldn't answer with existing technology, and couldn't afford to leave unanswered. How do you survive against an enemy who can see you coming? That question produced the F-117, a prototype born from trauma. An aircraft so ugly, so aerodynamically wrong, so contrary to everything aviation engineers believed, that it proved the only thing that mattered was whether it worked. It worked, but it wasn't enough. That question produced the B-2 Spirit, the proof of concept, the demonstration that a full-sized strategic bomber could cross the most defended airspace on Earth and strike without being detected. Magnificent, revolutionary, and so expensive, so fragile, so few in number, that the answer it provided was almost theoretical. And that question, the same question, asked for 54 years, refined by every failure, sharpened by every war, finally produced the B-21 Raider. Not just an invisible bomber you can actually use, that you can build in numbers, that you can deploy from anywhere, that you can sustain in combat for weeks, not hours, that can fly without a crew if the mission demands it. 3 generations, 1 question, each answer built on the wreckage of the one before it. And here's what I think that pattern tells us, not about bombers, but about how military power actually evolves. It doesn't evolve through planning, it evolves through failure. The Pentagon didn't sit down in 1972 and design a 50-year roadmap that ended with the B-21. Nobody drew a straight line from Linebacker II to Palmdale. That line was drawn by the enemy, by every surface-to-air missile that found its target, by every crew that didn't come home, by every limitation that made the previous solution inadequate. Vietnam created the F-117. The F-117's limitations created the B-2. The B-2's limitations created the B-21. Each failure contained the blueprint for the next breakthrough. The men who flew B-52s over Hanoi, the ones who survived and the ones who didn't, they couldn't have imagined the B-21. They couldn't have conceived of an aircraft that crosses enemy airspace without a pilot, without a radar trace, without any evidence it was ever there. But they made it possible, not because they chose to, because what happened to them made it necessary. And that might be the most important lesson embedded in this entire story. The innovations that matter most, the ones that genuinely change the balance of power, don't come from ambition. They come from the things that go wrong, from the disasters we can't afford to repeat, from the question that won't stop being asked until someone finally builds the answer. The B-21 Raider is that answer. And the ghost of Vietnam is finally flying. If you want to understand how stealth technology actually defeats radar at the physics level, how the shapes and materials interact with electromagnetic waves to create invisibility. I covered that in detail in my video on the Vilio B-2 Spirit's mission over Yemen. It goes deep into the science behind everything we discussed today. Link is in the card right now. I publish deep dives like this on military aviation history and technology every week. If you subscribe, YouTube will notify you when the next one drops, so you don't miss it.